Hello Minecrafters, and welcome back to another redstone video. This is episode 6 of learning redstone computer with Bedcraft, which is me. And in today's episode we were gonna discuss about program counter. So we were gonna explore what it is, what does it do, how to build one, and also how to connect it with our current computer parts right here. So without any further waiting, let's just jump right into today's episode. Before I explain what is a program counter, you should really check out Wing's video about program counter first to actually understand what is a program counter. But for the sake of simplicity and for our computer purposes, I will not gonna go in depth into how an actual program counter in a computer works. In Minecraft computer here, a program counter is basically, from my understanding, is a binary counter which counts up. And each binary number is equal to an instruction memory address, because if you remember, our instruction memory or Wing's instruction memory has an address system, and it goes from 0 all the way up to 1024, and the address are represented using a 10-bit binary number which goes from 0 all the way up to 2 to the power of 10. And the binary counter allows us to go from 0 all the way up to 1024. So essentially, a program counter allows us to execute a program stored in our instruction memory. If you remember previously, in order to execute a program stored in our instruction memory, we have to go from 0, and then 1, and then 2, and then 3, and then 4, and so on and so forth. And we also have to hit the clock signal, which is, I don't know, oh here. Yeah, this is the clock signal. So the program counter allows us to do this basically automatically. So how exactly do you build this program counter in Minecraft? Well, it's actually really simple, and there's a lot of methods that you can use to build a program counter. Like I have said, there are a lot of ways to build a program counter, but for simplicity again, I will be using Wing's program counter design. And if you don't know what that design is, again, you should check out Wing's program counter video first and then come back to this video, because that is our study material. You should really do research on your material first, your study material first, before actually doing these things. Okay, I have to rewatch that video several times in order to understand everything, okay, like any other Wing's educational videos, and you should do that as well. Anyways, in Wing's program counter design, he basically combined a register with an adder, and in diagram form it looks something like this. So we have a register over here, and this register will gonna be the output. It will be a 10-bit binary output over here, and this output will also be feed into this adder. This adder will basically just add 1 to this number, and the output will basically go back to the register. And in order to update the register, we have a clock signal. Now, what is this register and what is this adder? Well, fun fact, we have already built a register and also an adder before. For registers, they are basically these pin pots right here. We have built it inside of our register files. So each of these pin pots right here is actually a register. For our adder part, we have also built the adders already, and it is essentially this white pot right here, a CCA adder or a carry cancel adder. So we have built both of these pots before. All we have to do now in order to build a program counter is to combine the adder here with our registers over there. So the pink one, oh wait, I think you can see it more clearly over here. Yeah, so the pink one. So we combine the pink part with the white part, and we should be able to yeah, make a program counter. So let's do that in time-lapse 4. Okay, so here is our program counter. As you can see, it looks really nice. And the way that I built this program counter is very simple. So basically, you have two 8-bit binary address like this. You can grab one of these design in MapAdWing's logical redstone reloaded series in the addition video. I will link that video in the description. So you grab two of them like this, then you connect the carry out of the bottom adder with the carry in of the top adder. And since we only need 10 bits for the addresses of our instruction memory, we can basically remove the top 6 bits of this top binary adder. And then in order to add 1, is also very simple. You just activate this carry. As you can see, I just activate this carry, so now the number will always gonna be increment by 1. So of course you have to wrap the output back to the input, as you can see, and between the output and the input there will be a register, as you can see, and this register we're going to store the current number. Over here I also have a reset button. This is a feature that I don't see in MapAdWing's program counter, but I figured that I should add it in because I want to be able to reset the program counter relatively easy. So yeah, let's just see it in action. Every time I press this button, the program counter should count up by 1. So first is 0, and then 1, 2, 3, 4, and then 5, and then 6, and then 7, and yeah, it just keeps going up like that. It also has, like I have said, a reset button. So when I press that button, these lamps will open off, so like so. And the way that this reset button works is I basically just overwrite the output of the adder with 0, and then I unlock the registers or all of the latches here to basically write 0 into the register. And since they are all 0, all the lamps will turn off. The next thing that we need to do is to connect our output of the program counter here with the inputs of our instruction memory, which is this button or lever panel right here. So yeah, let's try to do that. Okay, so I have connected our program counter with the instruction memory. I have also color coded the program counter as white terracotta to make things a bit more, I don't know, like more different, so we can identify the program counter. And now what we need to do is we need to connect the clock signal of the program counter with the clock signal of our register file, because if you remember, in order to execute a program, you need to first input the instruction address over here, and then you need to press this clock signal so the data can go into the register file, and the result of the LRU can go into the register file. Okay, so I have connected the clock signal of the register file with the clock signal of our program counter. Now you do have to add some delay for the clock signal going into our program counter so that the LRU and the register file can fully process the current instruction. So right now the instruction is 0, so we need to wait for the LRU and the register file to fully execute that instruction before we move on to the next instruction stored in our instruction memory. Now I want to test our current program stored inside of our instruction memory to see if everything is working. So in order to do that, we just go into go to the clock signal here, and in theory every time I hit this button, the register file should update and the LRU should update, and we should be able to execute our previous program stored in our instruction memory. So yeah, let's do that. First instruction is instruction store at address 0, which is LDI R1 and then the number 4 if I remember correctly. So let's do that. We press the clock signal, and yeah, as you can see, the register file has number 4 at register number 1, and for our program counter it has counted up to 1. So now we have a new instruction over here. Now we are gonna load this instruction in by pressing the clock signal again, and we should see a new number at register number 2. So we can see that we have number 5 here stored at register number 2, and if we go to the program counter, we were gonna see that we are at address 2. So now we're gonna execute the instruction stored at the address 2. So now if I press the clock signal again, we should see that all 3, so it is R1, R2 and R3, register number 3 has number 9, and yeah, the whole program has been executed successfully just by pressing this singular button right here. However, pressing like this button is not really that nice. We want to automate this, and to do that we need to build a clock circuit. Now I will not gonna be going in depth into how to design a clock circuit for like a computer. My background has gone through this already, so again you need to watch the video first, like the study material first, and then come back to this video. Okay, but I'm basically gonna build a 10-second clock. So every 10 seconds we were gonna execute an instruction. Alright, so here's the clock, the 10-second clock. At least I think, I hope it is 10-second clock or very close to it. From what I'm counting here, it seems to be that it is a 10-second clock, but I can be wrong, I don't know. But yeah, this clock will be able to control both the register file and the program counter. But now there's a problem. How do we know when to stop this clock, you might ask? Because like, for example, we have basically finished our program, so we have gone through every single line in our every single instruction in our program, but because this clock keeps on like clocking, the program counter will still gonna count up, even though there's basically nothing left in the instruction memory for us to execute. Now the way that MapRedWing solve this issue is by implementing a new function called Halt, which is something that we have touched on before in the last episode. But now we're gonna add that Halt function into our Minecraft computer and not just like program. Okay, to add this inside of our computer, we have to go to our control ROM right here. Now we have to add a new function, which is Halt over here. So what do I mean by that? Oh, if we just grab an axe, basically void it, and we do something like this. So let me do this. Now we're gonna stack like so, and of course we have to connect this. So do this, do that. Now we have a new line in our control ROM. Okay, we have to reprogram this. So this is 7. So now we have to change this to 8 like this, and we're gonna place our, oh, this should be glass, and we're gonna place our repeater like this. So now if we put in opcode 8, we will be able to activate this line, and this line will gonna be Halt or HLT like in MapRedWing. I'm gonna write it as Halt like this so we can actually understand what this means. Now all we have to do is to add a new line over here, and this line will gonna go to this side of our, where is it? Oh, here. So it will basically gonna activate this block right here. So we have to wire it here to activate this RS latch, and this RS latch will determine whether the clock is on or off. Okay, so here is our operation for the Halt. As you can see, I have snagged the redstone to the correct spot of the clock right here, and now when the Halt signal is activated, this RS latch will be at this state, which means that the clock will gonna stop. Now in order to add the Halt like signal into our program, we basically have to add the opcode of the Halt into our program, which means we have to add 1000 these 4 lines right here into our program at the next address for the next instructions. So we have instruction 1 over here, instruction 2 over here, instruction 3 over here, and now if I go to the next instruction, which I think it is in like address number 3. This is address number 3. We go all the way up, and now we were gonna add the Halt signal like that. Now if we just go all the way down and reset this like that, we should be able to run this program automatically with just one singular button press, which is this button press right here. So when I press this button, the program will gonna run automatically. We are gonna have all of our numbers stored in here, and then the program will gonna stop, aka the clock will gonna stop. So yeah, let's try that. First I need to reset all of the things inside of the instruction memory. There we go. Now we are gonna go to our program counter, and then we're gonna press this button, and hopefully we should be able to see the program just automatically run. So I press it, and now we should see R1. Yep, R1 has number 4, after 10 seconds we should see, oh yes, R2, and then at R3, and we should see number 9. That's not number 9. That's pretty weird. Okay, something has definitely gone wrong. I'm not sure what, but yeah, something has definitely gone wrong. Now the debugging part will be quite a pain, and yeah, I will meet you guys back when I manage to debug this, I guess.
20 minutes later.
Okay, so there were a lot of problems. The first problem is over here. I did not know that this redstone torch is powering this redstone line, so I have to replace the sand wall with a transparent block here. Then for this halt line right here, the redstone signal did not reach the clock like the OR slash here, so the line never actually activate the OR slash over here. And then we have a bunch of timing issue with the register file, but you don't have to fix it. There's nothing to fix about the register file, just some timing issue. And finally, the reset line over here, I have to add a bunch of timing here, a bunch of delay in order for it to actually reset the program counter correctly. And oh, also you have to add a like 10 game ticker posts over here, or 5 redstone tick posts in order for the register file to actually work, because the register file works with button input, which is a 10 game ticks input. So this is a 10 game ticker post generator. So yeah, those are all of the problems. Now we can start trying out the program. Again, we have added the halt, which is here in our program. So in theory, I just need to press one button and the entire computer will be able to go through every single instruction stored inside the instruction memory, and yeah, that's and also it stops automatically. So yeah, let's try that. I'm gonna press the button, and now we're gonna go to the register file. We'll see that register 1 has number 4, and then after 10 seconds we were gonna see 5 at register number 2, as you can see. And now if we wait another 10 seconds, we were gonna see number 9 at register number 3, like so. And now if we go back to our program counter over here, we should see that it resets because the halt signal got activated. And yeah, as you can see, the OR slash has fully reset back to its initial state, and now we can rerun our program, as you can see. So yeah, that's all of the stuff that we need to do for today's episode. So yeah, I really hope that you have enjoyed today's episode, and I hope that you have learned something from today's episode. Thank you very much for watching again, and I will see you all in the next episode of Learning Rest the Computer with Backcraft. Have a nice day, everyone.